Good day, grade 10s. I hope you are doing well. Today we are focusing on a topic called trigonometry. Such a nice topic and a very easy topic. Okay, so questions from this topic will be given marks. We are just giving you marks, meaning you must get total for trigonometry. Trigonometry is a very easy topic. It just needs you to keep practicing and you will get all the marks. Okay, now this topic, trigonometry, is dated for 7 April 2020 on a Tuesday, and the lesson is for grade 10s. Okay, however, grade 11s and grade 12s, this would be a good starting point for you to understand the basics of trigonometry. Okay, now let us look at the lesson objectives. For today, we'll be looking at the introduction to trigonometry. We'll look at trigonometric ratios, or sometimes in short, we call these trig ratios, okay, together with what we call theorem of Pythagoras. Most of the time, I just call it Pythagoras, okay. We will also look into trigonometric equations. Remember, we have expressions and we've got equations. So with equations, we'll be finding the value of an unknown. All right. And then we'll look into reciprocals of the trig ratios. All right. And then on our lesson again, we'll focus on trig functions on Cartesian plane. Okay. Remember, your Cartesian plane is where we do most of the drawings, especially when we go to functions. Any shape in math that we want to draw, we draw it on a Cartesian plane. Okay, so we will look into trig functions where we draw them or we discuss them based on Cartesian planes. Okay, then we'll also look into what we call special angles. You'll see why they are special, these angles. Okay, and the other thing that you should note is I wrote part 1, meaning there is part 2 that you will need to also check after this session. Okay, so this is part 1, and then you must make sure that you also watch part 2 of this lesson. All right, now let us start. Introduction. What is trigonometry? Okay, I've written trigonometry in 3 parts. Okay, I've separated the word trigonometry in 3 parts. I wrote tri, I wrote gono, and I wrote metry. Okay, so tri in math means 3. Okay, then your gono means sided. Then your metry has to do with what? Shapes. So what do we know about 3-sided shapes? Those shapes are what we call triangles. Okay, remember, 4-sided shapes, we call them quadrilaterals. Okay, so in this case, we are dealing with 3-sided shapes, and these are your triangles. Okay, meaning most of our trigonometry will work with triangles. Okay, these are 3-sided shapes. Now, what do we know about triangles? Triangles have 3 sides and 3 angles. Please note that down. Triangles have 3 sides and 3 angles. Okay, so I've drawn for you triangle ABC, and this type of a triangle with that symbol at B, we call it a right-angled triangle. Why? Because that symbol at B represents a 90 degrees. So any right-angled triangle has one of its angles equal to 90 degrees. Okay, so triangle ABC in this case is a right-angled triangle. Okay, now remember, in trigonometry, very important, we label the sides of triangles with the angles facing those sides. Okay, like in this case, if I don't want to call side AB, okay, I can call it with what? Let's look at the angle facing side AB, that is angle C, right? So it means I can represent side AB with a small letter C. If I don't want to call side BC. Okay, I can label side BC with a small letter of angle A. So little a will be representing side BC. Okay, that is very, very important for you to understand. Also, side AC, we can label it as little b because it is facing the right angle B. Okay, now next, this is what I've just said to you in case you did not understand what I was saying. So triangle ABC and side AB, BC, and AC can be labeled as little a, little b, little c, with an angle facing that particular side. Okay, look at how we write angles. Okay, we write the letter of the angle with a cap on it. That cap, we call it a caret. Okay, a caret tells me that you are dealing with an angle. If you write A, B, C, I mark it wrong because it doesn't tell me that you are dealing with an angle. So in that case, I have to mark it wrong. Okay, same applies to if, for an example, you write 60 and you don't say 60 degrees or 50 degrees, you just say 50, then I will mark wrong in the case where you are expected to be talking about an angle. Okay, so angles, two important points. We represent the letter of an angle with a caret on top of it, as well as degrees on the value of the angle. Okay, very important. So I think I've already explained that side AB will be equals to little c, and side BC will be equals to little a, and side AC will be equals to little b. Okay, so BC equals to little a, and AC equals to little b. That is just very easy. You just need to know that and practice more and more. Now, when we are dealing with a right angle triangle, okay, remember we said a triangle has three sides and has three angles. You remember? Okay, so you may be asked to find any of the three sides, like find the length of any of those three sides in a particular triangle, or be asked to find any of the three angles in that particular triangle. Okay, so can we be able to find a side or an angle that is unknown if a question is asked? Yes. And how do we do that? We have two methods of doing that. Okay, so these methods, they will help us in order to find any side or any angle that is unknown of a right angle triangle. And what are these methods? The first method is called the trigonometric ratios. Okay, trig ratios. Then the second method is called the theorem of Pythagoras. Now, I want you, before we move on, to highlight the 2 points and know them. Okay, and also add that with your trigonometric ratios, you are able to find both an unknown side or an unknown angle. So meaning, trig ratios, you can either find a side or find an angle, meaning you use it for both. Okay, but when we go to theorem of Pythagoras, remember in grade 8, we only found the length of a particular side of a right angle triangle, meaning theorem of Pythagoras does not give you the option of finding an angle. You can't use theorem of Pythagoras to find an angle. Theorem of Pythagoras is only used if you want to find an unknown side of a right angle triangle. Underline, of a right angle triangle, not just any triangle. Okay, but with trig ratios, you can use trig ratios to find the sides of a triangle, a right angle triangle, or unknown angles. Okay, very, very important. Now, moving on, we're starting with our trigonometric ratios. What are these trig ratios? I've heard people talking a lot about these trigonometric ratios, and sometimes if you are not paying careful attention, you may be confused, but this is easy. Say, what are trigonometric ratios? Trigonometric ratios are relationships between sides and angles of a right angle triangle. Remember, we have three sides, three angles. So when I want to relate maybe two sides and one angle, or two angles and one side, or etc., those are relationships. It's like a relationship between a boy and a girl. So that is the same thing that is happening here. Okay, we are just relating the sides and the angles of a right angle triangle, and these are the relationships that we will get, and we call them trigonometric ratios. Okay, having said that, let's look at these relationships or these trig ratios. What are the trig ratios? We have the trig ratio sine, cos, and tan. Very important. Okay, so what does theta stand for there? The theta stands for an angle. And then on the right hand side, all of those up over hype, edge over hype, up over edge, they stand for sides. So meaning I'm relating the angle and the sides of a right angle triangle. Okay, these are the relationships, the trig ratios. So let us try and understand what these relationships stand for. Okay, starting with the sine. So sine angle theta is equals to, what is the relationship? So it will be equals to the side opposite angle theta over hypotenuse. Remember, hypotenuse is the longest side of a right angle triangle. So theta will be positioned in your triangle, and there will be a side facing theta, there will be a side next to theta, then there will be the longest side of a triangle. Now, when we have such a case, sine will therefore be the relationship that says sine theta is equals to opposite over hypotenuse. Okay, that's the first relationship. Now, the second relationship will be cos theta. What does cos theta stands for? It stands for adjacent over hypotenuse, meaning we relate angle theta with the side adjacent to theta and hypotenuse to theta, okay, or to the triangle. Now, cos theta is equal to adjacent over hypotenuse. Then the last trig ratio that we have for a right angle triangle is tan theta. What does the relationship say? It says tan theta is equals to opposite over adjacent. Okay, so tan theta meaning theta is opposite a particular side, then will be next to the other side. So that kind of a relationship, we call it tan. Tan, the angle theta, equals to opposite over adjacent. Okay, now when I take the first letter of sine, which is S, the first letter of up, and the first letter of hypotenuse, SOH, I get so. Then when I take the first letter of cos, arch, and hype, I get car. And then when I take the first letters of tan, up, and arch, I get tower. So when I relate all the three beginning letters of the relationships, I get what we call SOHCAHTOA. This is just an easy way of remembering the relationships. What do we call it? SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. These are your trig ratios. Okay. Now let us look at this triangle. Okay. It's a right angle triangle ABC with theta as one of the angles, and side AB, BC, and AC. Okay, what is the longest side in each of the two triangles? The longest side is side AC, which we call the hypotenuse. Okay, so in the first right angle triangle, theta is at angle C. Okay, meaning side AB will be the opposite side, and then side BC will be the side next to theta. We call it the adjacent side. Okay, so in the second diagram, I'm trying to show you that we must not cram to say always the opposite side will be here, the adjacent side will be here. No. It depends with the position of the angle that you are dealing with. I'm repeating it again. it depends with the position of the angle you are dealing with. Now look at the second diagram. Theta is at angle A, no longer at angle C. And what is happening now? Side BC is the opposite side to theta, and side AB is the adjacent. Adjacent means next to theta. Side next to theta now is AB. Do you see the change that has taken place there? So please, we are not saying always opposite will be here, adjacent will be there. It will depend with the position of the angle you are dealing with. Okay, now moving on. When you are dealing with trig ratios, okay, you will be asked to calculate the length of an unknown side or unknown angle. So long you have two given sides, you'll be able to find the unknown angle. So long you have one angle and one side, you'll be able to find the other side. Okay, so please just know that trig ratios help you to find both angles and sides, unknown sides of a right angle triangle. Okay, now let's go to example number 1. Take your time, pause the video, read the question, hide the answers, try to find it yourself, then go back and check the solution. Okay, take your time. Determine the length of AB. Okay, so if you look at the diagram, this is my AB here. Okay, determine the length of AB. How do I find AB? Remember now, I have only one angle other than 90 degrees. Leave 90. We're looking at the other angles. Okay, 90 is just telling us that this is a right angle triangle. We are focusing on the other given angle. So the given angle is angle C, which is 30 degrees. So we must relate this angle to the sides. So I'm looking for side AB, of which it is the opposite side to angle C. And I'm given the hypotenuse, side AC. So 30 degrees is opposite AB, hypotenuse AC. What is that? That is the sine trig ratio. So sine angle C equals to AB, opposite, all over AC, hypotenuse. When you substitute side angle C is 30 degrees equals to AB over AC was 8 units or 8 whatever. Okay, but the magnitude or the size of angle, the size of side AC is 8. Okay, the length of side AC is 8. So making AB the subject of the formula, we found that AB is equals to 8 sine 30 degrees. And this then therefore gave us AB being equals to 4 units. Remember, from your analytical geometry, I've always said it. When you are dealing with length, units are important. Okay. So in this case, you're not told whether it's centimeters, millimeters, meters, whatsoever. Hence, we will just say 4 units. That's what we do. Okay. Now, let's go to example number 2. Take your time, do it. Check the solution. Okay. Determine the length of the hypotenuse. Underline the length of the hypotenuse in the figure below. Now let us go to the figure. This is the figure. Okay, what is given? We are given angle A, which is 60 degrees. We are given side AB, which is 5 units or centimeters or whatever. And then we are asked to find the side of the hypotenuse. Okay, find the hypotenuse. Now, the hypotenuse in this triangle is AC. Now, let's check. How does the hypotenuse and the given side relate to angle 60 degrees? 60 degrees is next to AB, adjacent to AB, and hypotenuse to AC. So, that is cos trig ratio. So, cos angle A equals to adjacent AB all over hypotenuse AC. Therefore, when you substitute there, it's cos 60 degrees equals to 5 over AC. Then we make AC the subject of the formula. We find that it is 5 over cos 60 degrees. Therefore, AC equals to 10 units. Okay, we say units because We were not told whether it's meters or centimeters or whatever. Okay. Now moving on, let's go to example number 3. We are dealing with what? Trig ratios. Okay. So now they are saying if cos theta is equal to square root 2 over 2, determine the size of theta. Wow. In the previous cases, we were looking for length of a side. But in this case now, we are looking for the unknown angle theta. How do we find angle theta? So we look at theta. Theta relates to the given size in this way. BC next to theta, AC hypotenuse. So that is cos. I think it's already given. So how do we find cos? Very important. Most of the learners are still struggling with removing the cos there. Look at the cos there. Remember, the only thing we need to get rid of there is the cos, so that we find what is theta. So if the cos is gone, I'm left with only theta, and that's what the question is asking me to do. So what do we do? In your calculator, look for a button that says shift. You punch on the button that says shift, then it will give you an option to punch in your numerical ratio, which is root 2 over 2, and then you say equals to, find the answer. Then when you do that, this is how it will look like. Immediately say shift cos, then you are getting cos to the power negative 1. This is an inverse of cos, okay? Inverse of cos. That is not exponent minus 1. Please don't say 1 over. Okay, very important. So, we are getting theta being equals to 45 degrees. I hope that is very, very clear. Now, well done. Let us go to example number 4. So, with example number 4, what is happening? If sine x is equals to 4 over 5, here we are given the relationship. You don't need to start by drawing the diagram. Okay, just find what they say you must find. Determine the size of x, x being the angle, right? So what do? I know that for me to find x, I must get rid of the sine. How do I get rid of the sine? That is when I say arc sine or shift sine 4 over 5. Therefore, I found that my x is equals to, I don't know how many degrees you have rounded off your answer, but let us, in the case where we are not told, round off to 2 decimal places. Usually, this is in your exam instruction and information page. 2 decimal places at least. Okay, so this gave me 53,13 degrees. Well done. Now, let us go to the next part of the session, which are reciprocals. Very important. Guys, what's a reciprocal? I have learners who still struggle to understand what we mean when we are talking about reciprocals. This is very important in our trigonometry because it will help you to understand the other parts of this lesson. Okay, so if I have 1 over 2, what will be its reciprocal? Very important. Okay, so its reciprocal will be a number that will multiply with 1 over 2 and the answer giving us 1. Okay, so 1 over 2 times what? Times 2 give us 1, meaning the reciprocal of 1 over 2 will be 2. Okay, when we multiply the two numbers, the number itself and its reciprocal, we must get 1. Okay, now let us look at the next slide. If I have 5 over 3, then I ask you, what is the reciprocal of 5 over 3? It is the opposite of that, which will be 3 over 5, because when I multiply the two numbers, I'll be getting 1. Okay, similarly, in our trigonometric ratios, we can get their reciprocals. Okay, trigonometric ratios also have reciprocals, and let us look into that one. So, what do we call the reciprocal of sine? They have their special names, and you need to know them and learn them. Okay, the reciprocal of sine, which is opposite over hypotenuse, is what we call cosec. Okay, meaning cosec will be hypotenuse over opposite. Okay, so if sine theta is equal to 3 over 2, then what will be cosec theta? Cosec theta will be the opposite, 2 over 3. Okay, let's go to cos. What do we call the reciprocal of cos? It has its own special name. We call it sec. So if cos alpha is equals to negative 1 over 2, then what will be its reciprocal? Sec. Sec alpha will therefore be the opposite, negative 2 over 1. Well done. Now let us look at the last one. What is the reciprocal of tan? We call it cot. So if tan beta is equals to square root 3 over 3, then its reciprocal cot beta will be equals to the opposite, which is 3 over root 3. It's like we are just inverting, changing. The top goes bottom goes up, and those are reciprocals. Okay. Now note, if the sine, the cos, the tan are given as positive ratios, then their reciprocals are also positive. I hope you have checked as we were doing in the above slides. Okay, very, very important. Now, let's recap quickly. What does that mean? If cosec, sec, and cot are reciprocals of sine, cos, and tan respectively, then what does that mean? It means cosec theta will be equals to 1 over sine theta. Okay, and sec theta will be equals to 1 over cos theta. And cot theta will be equals to 1 over tan theta. Okay, and the opposite is also true. Sine theta will be equals to 1 over cosec theta. Cos theta will be equals to 1 over sec theta. And tan theta will be equals to 1 over cot theta. These are your reciprocals. Okay, very, very important. Now let's look at example number 5. Use a calculator to determine the value of sine 30 degrees and cosec 60 degrees. Guys, remember, we don't know what is cosec. We don't have cosec in the calculator. So that means I have to use what I know. And what I know is cosec 60 degrees is the same as 1 over sine 60 degrees. I have sine in the calculator. Okay, so sine 30 degrees is 1 over 2, which is from the calculator, multiplied by cosec 60 degrees is 1 over sine 60 degrees. Therefore, I'm getting 2 root 3 over 3 multiplied by half, and my answer is root 3 over 3. So reciprocals are easy, please. These are just fancy words, like somebody who's called Bongani. His friends won't call him Bongani. They will call him with all sorts of different nicknames, like the bongs, and all of those. Okay, so also these are reciprocals, just fancy names, but easy stuff, okay, to do. Now let us go to the next one. Please find this using your calculator. Okay, I have cot. I see cot there, but in the calculator I don't have cot. But I know the relationship between cot 60 degrees and tan. What is the relationship? Cot 60 degrees is equal to 1 over tan 60 degrees. Right? So cot 60 degrees is 1 over 2 multiplied by, we said what is 1 over tan 60 degrees? It's root 3 over 3. And when you multiply, then you got root 3 over 6 as your answer. Well done. And I hope we are moving together. Okay, now we are done with reciprocals, and we want to look into trigonometric functions using theorem of Pythagoras. Okay, now let us say I have point P. Okay, and point P, we know it will be representing an x value as well as the y value given as a coordinate point. Okay, and this is in the first quadrant, point P. So do you agree with me that I can actually analyze point P in this manner, where if I join the dot from point P to the x-axis vertically, and I join point P to the origin diagonally, then I'll be getting a right angle triangle. Wow, wonderful. We are getting a right angle triangle, and we know that when we are dealing with a right angle triangle, trig ratios may be applied. Well done. Now, from point P, we were given the value of x, we were given the value of y, and we jot it down on the Cartesian plane. This is what we call the Cartesian plane. The y-axis, the x-axis crossing each other perpendicularly, then we have our Cartesian plane. Now, look at what is happening there. I have my x, I have my y, and they are forming a right angle triangle. Now, when you look from point P to the origin is where the x-axis and the y-axis cut each other, I'm getting the length r. What is r? R, usually we call it the radius, but in this case, we will call it the terminal arm. Okay, this is our hypotenuse, because r is the longest side of the right angle triangle. You get that? Very, very important. And then, when you look at the position of theta, theta is opposite, y is adjacent, x, hypotenuse, r. Now we are sorted. Okay, but remember, using our trig ratios, this is the relationships that we will have. Sin theta will be, in terms of x, y, and r, it will be y over r. Then its reciprocal will be r over y, the opposite. Cos theta will be x over r, adjacent over hypotenuse, right? Then its opposite will be sec theta equals to r over x. Look at the relationships there, okay? Then tan theta, looking at the diagram, will be opposite over adjacent, which is y over x, and its opposite will be cos theta, which will be x over y. Very, very important. Okay, now having said that, we may have our right angle triangle drawn in the first quadrant of a Cartesian plane, or in the second quadrant, or in the third quadrant, or the fourth quadrant. This is what we call the first quadrant. This is what we call the second quadrant. This is what we call the third quadrant. And this is what we call the fourth quadrant. Okay, so our right angle triangle may be drawn on any quadrant when we are dealing with our trigonometric ratios. Okay, now, having said that, what is the easy way of remembering this? Okay, the easy way that I normally advise learners to think of is a bow tie. Okay, if I have my bow tie, remember, okay, let me draw a bigger picture. If I have a bow tie, remember, a bow tie will look something like this, if you remember. Okay, so if you have your bow tie in your head, then you will know how your triangle must look like in each of the quadrants. Okay, let's go to an example. Example 6. Using the diagram below and without the use of a calculator, determine, okay, we'll see the questions. So this is the diagram, and we are given a point 6, 8. Okay, that's the point, 6, 8. What does 6 represent? X. What does 8 represent? Y. So with an 8 of a diagram, this is what we are having. How do I find R? Very important. How will I find R? Using what we call theorem of Pythagoras. So the theorem of Pythagoras will say the square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, my R squared equals to 6 squared plus 8 squared, which is 100. Then I take the square root both sides. Then R is equals to 10 units. Why did I not say plus or minus? That is because R is a length, and length is always positive, regardless of where R is situated in the Cartesian plane. R is always positive, and I think I have highlighted it there. R is greater than 0, meaning R must always be positive. Only X and Y can be anything, but R must always be positive. Okay, so I think that's the question. A, find sine theta using this diagram. Okay, remember sine theta is opposite, which is 8, over hypotenuse, which is R, but we already know R is 10, therefore the answer is 8 over 10. When you simplify, it's 4 over 5. Then the second question is B, cos theta. Okay, what is cos theta? We said cos theta is X over R, so we just plug in our values. What was X? 6. What was R? 10. When you simplify further, it is 3 over 5. Then the next question is 5 tan theta. Tan theta, in terms of X, Y, and R, it was Y over X. We just plug in our values. Y is 8, X is 6. When you simplify further, we get 4 over 3. Okay, then D, question D, find sine theta and cos theta using this diagram. Okay, so when I'm using this diagram, I notice that my sine theta is 8 over 10 divided by my cos theta is 6 over 10, and therefore 8 over 10 is 4 over 5 divided by 6 over 10 is 2 over 5. Then I change division to multiplication, and what am I getting? I will tip and times. The 5 will go up, the 3 will come down. That's why I wrote it in a different color so that you see. When you tip and times, only the part on the right is changing. Leave the left. Okay, 4 over 5 remains as 4 over 5. Now 5 and 5 cancel. I'm getting my answer as 4 over 3. Okay, then we have the last, second last question, E, which is sine theta over tan theta. You must find this answer, simplify this. Okay, so from the diagram, sine theta is Y over R. Therefore, my Y was 8, my R was 10. I found it. Divided by tan theta. Tan theta is Y over X. My Y was 8. Then my X is 6. Then I simplified 8 over 10 as 4 over 5. Simplify 8 over 6. I got 4 over 3. Okay. Then changed division to multiplication. Remember, tip and times. But what goes up, what comes down? The stuff on the right. Okay. Then my answer was 3 over 5. Last one. We must find sine squared theta plus cos squared theta using the diagram here. Okay. Now, before we do this one, I want to explain something to you. Sine squared theta can be written as sine theta all squared plus cos squared theta can be written as cos theta all squared. What we are just saying here is we are having something like sine theta times sine theta, cos theta times cos theta. So you can just read them to the power of 2 each. Okay. Now what is sine theta? It's 8 over 10 all squared. Plus what is cos theta? 6 over 10 all squared. Now 8 squared, 64 over 100 plus 36 over 100, and therefore our answer became 1. Please take note of this answer. End of the lesson, you will see something. Okay, sine squared theta plus cos squared theta equals to 1. You will see something before the end of the lesson. Very important. Now, let us go to example 7. Example 7, they are saying using the diagram below, this diagram, okay? And without the use of a calculator, determine the value of, okay, we'll look at the questions. Let us look at what is given. We are given point Q, okay? We are given point Q, there is point Q, of which we have X, and there is X on the diagram, we have 12. But remember, 12 represents Y. So there we go. Now, okay, also, we are given on the diagram 15, but 15 represents R. You remember? Now it means, what is it that we don't have? We don't have X. So we can find X using the theorem of Pythagoras. Why must we find X first? Because when we go to questions will be revolving around X, Y, and R. Okay, so using the theorem of Pythagoras, R squared is equal to x squared plus y squared. Okay, substituting, then we find that our x is plus or minus 9. But remember, the diagram itself was shown to be on the first quadrant, meaning our x must be a positive 9 on the first quadrant, right? All values on the first quadrant here are positive. All the x values, on this quadrant, they are positive. Now, the next thing is we answer the questions. Now, they say determine the value of cosec theta. Remember, cosec theta is the reciprocal of sine theta. So sine theta is y over r. Therefore, cosec theta will be r over y. Substituting, r is 15, y is 12. Answer then became 5 over 4. Then sec theta, remember, is the reciprocal of cos theta. Cos theta is x over r. Therefore, sec theta will be r over x. And r was 15, x was 9. Therefore, answer is 5 over 3. Well done. Now, cos theta is the reciprocal of tan theta. You agree with me? Therefore, if tan theta is y over x, then cos theta will be x over y. And our x was 9, y was 12. Then my answer became 3 over 4. Okay. Then tan theta times cos theta. That's the next question, D. You must find that. Now remember, what is tan theta? It is y over x, and my y was 12 over my x was 9, multiplied by cos theta. Remember, is the opposite of tan theta, which will be x over y. Therefore, it will be 9 over 12. Multiplying, we got 1. Well done. You see what I was telling you. When you multiply the reciprocals, your answer will be a 1. Well done. Now, moving on, we go to quadrants. I've heard some people say, what are quadrants? Say, what is quadrant 1? What is that? Okay, so we want to look into quadrants, okay? Let us look at what quadrants are. When you have your Cartesian plane, it has 4 parts, okay? And these 4 parts, we call them 4 quadrants of a Cartesian plane. We just call them quadrants. Remember, this is math, so we must have our own special language, right? We can't say 4 parts. That is English, and we want mathematical terms, okay? So, mathematical terms that we use here are quadrants. So, on my screen, I showed you which one is quadrant number 1, and it doesn't change. It will always be like that. And then quadrant number 2, quadrant number 3, quadrant number 4, quadrant number 5, and you need to know these, okay? Again, I've showed you, if we have a protractor, you know a protractor, that's a mathematical instrument. We measure angles with a protractor, and therefore, we start from 0 degrees, okay? So when you place your protractor, then you will be placing it in this way, okay? Then it will start measuring from 0. Then as you move on and on and on, you notice that at this point, you are getting a 90 degrees. Then where the protractor ends, which is this point here, you are getting a 180 degrees, okay? But if you now put another protractor, it will give you a full 360 degrees, and we call that revolution most of the time, okay? Now, this is very important for you to know because it will apply in the next slides, okay? Now, when we measure angles, measuring angles, you need to be very, very careful of your direction, okay? How you move, your movement is very important in trigonometry when we are dealing with the measurement of angles, okay? So when you measure an angle clockwise, then you will be getting a negative angle. Remember, negative angle doesn't mean the angle itself is negative. The negative means you are moving clockwise, right? Also, moving anti-clockwise, you'll be generating positive angle. The angle is positive because you are moving anti-clockwise. I've showed you how clockwise and counterclockwise look like, because some people, they usually get confused, okay?
So clockwise is the direction of the clock. Anti-clockwise is the opposite direction to the movement of the clock. Okay, very important. Please note that. Now let's look at how the direction affects the angle. Okay, so look at the first diagram. I have measured from 0 degrees. Remember, 0 degrees is here. Okay, I have measured from 0 degrees angle theta. Theta can be anything, but you know it's less than 90 degrees. It's in first quadrant. Okay, so I've measured angle theta, and looking at the arrow, look at my arrow there. My arrow is showing you that I'm moving anti-clockwise. That's why my theta is positive. Look at the second diagram there. Okay, what do I have? I have 60 degrees. Why is it positive? Because my direction is anti-clockwise. Look at the third diagram. I have what? A positive 105 degrees because the direction is anti-clockwise. So all anti-clockwise angles will be written as positive angles. Okay. However, when we measure our angles anti-clockwise, look at the direction of the arrow for the first diagram. It's clockwise. Therefore, the angle will be negative theta. This is also true if now I give you numerical values for angles. A clockwise movement will give us a negative radius. In this case, we have negative degrees, and the last one we have negative 100 and that cannot be 108. Okay, that cannot be 108. That cannot be 108. This, however, can be, let's say, negative 100. Okay, this negative 100 degrees, very, very important. Or it can also be, yeah, it can also be 108 because it is less than negative 180. Yeah, okay, sorry. But you can also use the 100 degrees, okay? Don't feel bad. You can get that. Very, very, very important. I thought it's negative, I don't know, something. Okay, now, negative 108 degrees. Negative because we are moving clockwise. Okay, very important. Now, moving on. Now I'm giving you 180 degrees plus theta. And as I'm giving you 180 degrees plus theta, what does it mean? We have two angles added. 180 and 80. So 180 is positive, meaning from 0 degrees I'll measure 180. All the way from 0, there is 180 up to here. Okay, that is positive 180 degrees. Positive 180 degrees. And then where I stop, the angle that I have here tells me to continue in the same direction because it's positive, anti-clockwise. So when I moved a further degrees, remember theta is very small. Smaller, very, 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 very small. It's an acute angle, very small, okay? So when I moved theta degrees in the same direction, anti-clockwise, then I landed in the third quadrant, and the whole of this angle then is my 180 plus. Let's look at the next one. Minus 180 minus 6. I have two negative angles, meaning from the origin, not from the origin, from 0 degrees, I measure 180 degrees. In which direction? In the clockwise direction. Then this is your negative 180. But where I stop, I must continue what? Theta degrees clockwise because I have negative theta. So this is your negative theta. And the whole of this angle here is our negative 180 degrees. Negative theta. Okay. Those are how we measure angles. Okay. Now let's look at the quadrant. What is happening in quadrant number 1? When I look at the trig ratio sine cos tan, I find that the y values and actually we have the x-axis and the y-axis, right? So in the first quadrant, the parts of the axis that we are looking for, we find that the x and the y-axis both are positive. So that makes the ratio, any ratios of sine, cos, and tan to be positive. So hence I said, in this case, all the trig ratios in the first quadrant will be positive. All right? And then, in the second quadrant, what is happening? We look at the x and the y-axis in the second quadrant. All right? We find that
when we look at in relation to the ratios, the trig ratios, sine, cos, tan, only sine is positive in the second quadrant. Okay, meaning when I divide the x and the y and the r in the second quadrant, looking at the axis, then only sine became positive. Okay, then similarly in quadrant number 3, when I looked at the axis in quadrant number 3, the x-axis is negative, the y-axis is negative for the third quadrant, and therefore only the tan trig ratio would give us a positive ratio. Okay, then lastly, in quadrant number 4, what is happening? Looking at the x-axis, it is positive, and the y-axis is negative. Meaning all x values in the fourth quadrant are positive, all y values in the fourth quadrant are negative. That's what I'm talking about. Okay, so when we looked at the trig ratios, we find that only cos was positive, okay, in that quadrant number 4. This is very important. And how did I summarize this? I've done it in a nice way for you. Okay, in quadrant number 1, all positive. Okay, in quadrant number 2, S, meaning sine is positive. Quadrant number 3, only tan is positive. I wrote T. Then in fourth quadrant, only cos is positive. I wrote C. When you write the letters down, C, A, S, T, this gives you cast. Okay, this is a nice way of remembering cast. It's a mnemonic that we use in order to remember what is positive where. So from the fourth quadrant anti-clockwise, we get cast. Okay, very important. Now, let us apply our cast as well as the trig ratios in example number 8. If sine theta is equals to 3/5 and theta must lie between, that's how you must read it, okay? I repeat again, theta must lie between 90 degrees and 270 degrees. Then, what will be the value of cos theta times tan squared theta? Okay, so these are your hints. You must use them in order for you to come here. And usually, these problems, they require you to have a please note it down, a diagram. Okay, the first starting point of this type of questions is a diagram. Now let us see how we use those two hints which were given. There we go. Sine theta equals to 3/5. What do you notice about the 3/5? That ratio is positive. And 3 represents y, 5 represents r, meaning we need to find our x. But nevertheless, sine is positive. We are looking for where sine is positive. Let us see. Sine is positive in the first quadrant, you tick it. Also, sine is positive in the second quadrant, you tick it. I've used red to tick the quadrants. But we are done with the first hint. Now we must come to the second hint. Second hint is theta must be between 90 degrees and 270, meaning between quadrant 2 and quadrant number 3. I used green to tick those quadrants. So I have a tick in the second quadrant in green, a tick in the third quadrant in green. Then you ask yourself, where do I have most ticks? I have most of my ticks in the second quadrant, meaning that's where I have to draw my right angle triangle. Don't forget to find x, because we have only y and r, 3, 5, right? You need x. Well done. That's how you must analyze the questions. So I'm starting by finding my r. I know that my diagram must be in the second quadrant. What do I know? I know that all the x values here on the second quadrant are negative x values. You remember, all the values are in the second quadrant, x values are negative. Okay, so as I'm finding my r using theorem of Pythagoras, my x is equals to plus or minus 4, but I know that I'm in the second quadrant, therefore my x is only -4. Okay, then I drew my sketch using bow tie. You remember bow tie? We said your bow tie will help you to draw your triangle. Therefore, I have my x -4, I have my y 3, I have my 5, which is r. Then look at the way the angle theta is placed. Okay, theta is placed there, but please learners, take your theta as if it's inside there. Okay, very, very important. You can also verify that using your relationships, whether theta is at the right position. Okay, now moving on, the first question said we must find what? Remember, we were given that we must find cos theta times tan squared theta. This is the question. Okay, so finding that, what is cos theta? It's x over r. What is my x? -4 over, what is my r? 5. Multiplied by, remember tan squared theta is the same as tan theta squared. But what is tan theta? It will be y over x. What is my y? 3. What is my x? -4. All squared. And then when you multiply that, the answer is -9 over 20. Okay, very important. Now, these are the common mistakes that people usually do. Okay, look at what we had here. Okay, we were having theta there and having theta there. Guys, you can't substitute. You can't say, look at this. You can't say where there is theta, that's where you put your values. Okay, you can't. Theta is an angle. Theta is an angle. Okay, so please don't say cos negative that, tan squared that. No, no, no. Theta is an angle. Therefore, the whole of this thing here, cos theta, tan squared theta, will be represented by the correct substitution, and that being the answer. Okay. Now, did you know that r is always positive? Yes, we know. Did you know that r is called the terminal arm? Yes, we know. Okay. Now, good. Example 9. Example 9, same problems, but I want you to try it. Pause the video and try example 9. Okay. If tan theta is equals to square root 3 over 3, you see tan theta, the ratio is positive, meaning we are going to tick on the quadrants where tan is positive. And remember, tan in terms of x, y, and r is what? Y over x, meaning our square root 3 is y, 3 is x, meaning we must find our r. But also, root 3 over 3 is positive, meaning we must tick the quadrants where tan is positive. Then they are saying and cos theta less than 0. Let's talk about less than 0. Less than 0 means what? We are looking for where cos is negative. Less than anything, less than any number less than 0 is negative. So we're looking for where cos theta is less than 0, where it's negative. Right. Now, determine the value of ABC. Find our R, and then our length of the quadrant, and then I showed you the relation that theta is positive. The way it can be the positive is the first quadrant and the third quadrant. Right. Then cos theta, look at this, less than 0.
Now in red, I want you to
Not on the day. Because all values of x here are negative. All values of y here are negative. Hence, I must write that value of x and y, they are negative.
it doesn't affect now moving on. Our R now
Cos theta, it is x over r. With substitution, the answer became 3 over square root 3. Well done. Now, moving on, we have square root 3 cot theta plus cos squared theta times sin squared theta. We must find this, okay? Square root 3 is square root 3. It doesn't change. It's a constant. There we go. Then cot theta is the reciprocal of tan. Therefore, it will be x over y. And we substituted minus 3 over minus root 3 plus cos squared theta is cos theta squared, which is x over r all squared. There we go, substitution. Then sin squared theta is sin theta all squared, which is y over r all squared. The answer became 51 over 16. Well done. And then that brings us to special angles. Special angles. These are angles that are special. This is so wonderful. Special angles, angles which are special. Nice name. Okay, so which angles are special in trigonometry? 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Oh well, that's good. Not bad. We can manage to remember or recall that. But say, what is the easy way to remember these angles? We use triangles. Okay, that triangle, this triangle, and the triangle D. Okay, so we use 3 triangles in order to make our life easy, and we can apply these special angles. So what are special angles, guys? Special angles are angles that we can find when we use them with our trig ratios without using a calculator. Underline. When I say without the use of a calculator, that's a hint to say you can find this without using or punching the calculator. These are special angles. You know these angles. These angles are those special angles. 0 degrees, 30, 40, 60, and 90 degrees. We can use our special angles, triangles, to find the values, to determine the answers. Okay, so let's look at the first triangle. The first triangle has 60 degrees, 30 degrees, and 90 degrees. Remember, sum of angles in a triangle must add up to 180, right? So, if I give you that one side in that triangle is 1, the other side is square root 3, how would you find the hypotenuse? Using the theorem of Pythagoras. Therefore, the answer is 2. Okay. And then, if now in the second triangle, I have 45 degrees, which add up to 90, plus the other 90. Therefore, we are getting 180. What do we know about this triangle? This is a what? A right angle isosceles triangle. Remember, two base angles equal, then two sides of that triangle will be equal. Isosceles triangle. Remember. Now, if I give you that one side is 1, what do we know about the other side? It will be 1 because two sides of this triangle must be equal. Isosceles. Right. Then how do we find the hypotenuse? The hypotenuse will find it using the theorem of Pythagoras. Therefore, we'll say 1 squared plus 1 squared, which is just 2. Then take the square root of r squared. Then we are getting r to be square root 2. Okay, so we've spoken about 30, we've spoken about 60 degrees, we've spoken about 45. Therefore, now we need to go and check 0 degrees and 90 degrees. Now, there we go. 90 degrees and 0 degrees are summarized in this triangle. Okay, now, when I have 90 degrees and 0 degrees in that triangle, when you add all of them, 90 degrees plus 0 degrees, it's 180 degrees. Sum of angles of a triangle add up to 180. We are happy. Now, if I give you that the hypotenuse is 1, then I give you that the other side is 0. How do you find the other side? Or maybe I give you one side to be 0, and the adjacent side also, or the base is 1. Then finding the hypotenuse, we're going to say 0 squared plus 1 squared, which is 1. Square root of 1 is just 1. Then we are happy. Okay. I know this part here usually confuses people, but I will explain this in the next session, why this is 0 there. Okay. Very, very important. Now, when we look at this, what is your tan 90 degrees? Remember, tan is y over x. So from my diagram, my y is, remember, tan 90 degrees is also opposite over adjacent, right? So 90 degrees there is opposite what? It's opposite the 90 degrees here, okay? Is opposite 1 and is adjacent 0. And therefore, we are getting an undefined. Why? Because division by 0 yields an undefined. Okay, very important. That is why the tan graph, when you sketch the tan graph, it has asymptotes where we get 90 degrees. That is because at that angle, 90 degrees, then we are not having a solution. I wrote no solution. Okay. Asymptotes. We'll talk about that. And then the other thing that we have before this slide is an example. Okay, so this example is based on the trig ratios that we have already covered, and we want to look at how do we determine answers to these trig ratios without the use of a calculator. Okay. So the first one that we have there is sine 30 degrees, and we can use our special angles to find the answer in this case. Okay, how do we find the answer to this case? Remember, sine 30 degrees is opposite over hypotenuse. But do we have a triangle which has 30 degrees as one of the angles? Yes. Therefore, we are going to go to that triangle and look for the answer. So when we go to that triangle, we find that, let us check, 30 degrees, you see 30 degrees in the first triangle, is opposite 1 and is hypotenuse to 2. That's why then our answer, which is sine 30 degrees, will be equals to a half. Okay, let us look into that one. Our answer for sine 30 degrees will be equals to half. What will be cos 30 degrees? Using the same triangle, it will be root 3 over 2. Tan 30 degrees will be 1 over root 3. Let's check tan 30 degrees. You see, opposite over adjacent, 30 degrees is opposite 1, is adjacent root 3. Okay, we are happy. And then the other thing that we notice is that we are having cos 60 degrees, and cos 60 degrees, remember, it will be opposite over hypotenuse. So looking into this triangle, 60 degrees is opposite root 3 and is hypotenuse 2. That's why we get root 3 over 2. And then cos 45 degrees is 1 over root 2, and tan 90 degrees is undefined, and we have used this triangle particularly, right, which is the third special triangle. Please know these triangles by heart. They won't be given in the exam. You need to know them, memorize them, and be able to apply them. Okay. Now, why does my calculator give me square root 3? Because when I use the triangles, I'm getting 1 over root 3. Oh, why am I getting square root 2 over 2 in the calculator, but my triangles give me 1 over square root 2 when I punch sine 45 degrees, or when I punch tan 60 degrees? That is because we said when you use those triangles, you must not use a calculator without the use of a calculator. So a calculator, immediately you punch in tan 60 degrees, it gives you square root 3 over 3 because of it rationalizes the denominator. Also, when you punch in the calculator sine 45 degrees, it gives you square root 2 over 2 because it rationalizes the denominator. That's how we catch you if you have used the calculator. Without the use of a calculator, then a learner will write 1 over square root 2 and will write 1 over square root 3, unlike where the answers are already rationalized. Okay. Having said that, let us look at what it means to rationalize. This is what it means. Rationalizing the denominator. Your answer from the triangles is 1 over square root 2. What does the calculator do? The calculator multiplies the numerator and the denominator by the denominator that you have. Now, in the first example, my answer was 1 over square root 2 without the use of a calculator. So the calculator then rationalized by the denominator. That means to what? To multiply your answer, okay, to multiply your answer by the denominator top and bottom. So that is to say times square root 2 over square root 2. That is the same as multiplying by 1. Anything or any number multiplied by 1 remains unchanged. We get the same number. Okay, that is to rationalize. Hence, the answer then became square root 2 over 2. Similarly, you had 1 over square root 3 from the triangles. But when you punch the calculator will give you this answer, square root 3 over 3, because the calculator has actually, okay, let me fix this, because the calculator has actually multiplied by 1, that is to rationalize by the denominator, multiply the top and the bottom by your denominator. Okay, hence the answer became square root 3 over 3. Okay, well done. That is to rationalize. That's what the calculator has done. Now, let's go to example 10. Example 10, what do we have? Without the use of a calculator, determine the value of sine 30 degrees, cos 60 degrees. Do you know your special angles now? You must know your special angles. Okay, using the triangles and without, underline, the use of a calculator. Alright, meaning you can't use your calculator, you must use your special angles, which we have covered in the slide here. Okay, you must use your special angles, which we have covered in this slide here. Okay, so let us find sine 30 degrees times cos 60 degrees without the use of a calculator. What is sine 30 degrees? Using your special angles, it's 1 over 2 multiplied by. What is cos 60 degrees? Okay, cos means adjacent over hypotenuse, and therefore it's 1 over 2. That's why I wrote 1 over 2. But what is 1 over 2 times 1 over 2? You multiply the top and the top, the bottom and the bottom, and the answer is 1 over 4. Well done. Now, let us go to B. We must find tan 45 degrees times cos 30 degrees. Is 45 degrees and 30 degrees special angles? Yes. Meaning, you are not allowed to punch the calculator. You must find the answers on your own by using the aid of what? Of the triangles from special angles. Now, what is tan 45 degrees from the triangles? Let us look at that. You can choose any of the 45, either this one or this one. 45 is 45, it doesn't change. But tan means opposite over adjacent. So 45 is opposite 1, adjacent 1, which is 1 over 1. Okay, so that's why I wrote 1 over 1 multiplied by, what is cos 30 degrees? Cos 30 degrees is square root 3 over 2 from the triangle, and my answer just became square root 3 over 2. Good. Now, see, sine 45 degrees times cos 45 degrees from the triangle. Let's look at this one. Okay. Looking at this one, see, using this triangle, what is sine 45 degrees? It's 1 over square root 2. What is cos 45 degrees? Adjacent to 1, hypotenuse to 2, square root 2. Therefore, I'll be having 1 over root 2 times 1 over root 2, which is 1 times 1 is 1, square root 2 times square root 2 is 2, and my answer being half. Those who use the calculator, who will catch you, because your answers for sine 45 degrees would be square root 2 over 2 times square root 2 over 2, which you did not follow the instructions. We have used the calculator. Okay, very good. Now, having said that, we're done with example 10. We are now at example 11. Okay, where now we are giving you a higher order question. Example 11 says, in rectangle ABCD, let's look at rectangle ABCD, there is a rectangle. Remember, when I covered analytical geometry with you, I said you must know the properties of your quadrilaterals, your square, your rectangle, your trapezium, your parallelogram, as well as the rectangles. Okay, because they will be part and parcel of any topic in the exam. We will integrate the topics. So if you are not aware or you are not familiar with your properties for the quadrilateral, that means you will not be able to answer the questions. So like this question here, we are given triangle ABCD and we must answer the questions. So below, AB is 4 centimeter. So let's look at AB. AB. There is AB. AB is 4 centimeter. What will be side DC? Before we even continue, side DC will also be 4 centimeter. Why? Because both pairs of opposite sides of a rectangle are equal and parallel. This was not given to us, but it's one of the properties of a rectangle. Okay, so angle ABE. Let us look at angle ABE from the diagram. There is angle ABE is 45 degrees. But if the whole angle B is 90 degrees, then it means we can also find the other angle, which is 45. Okay. Now, angle BEC is 75 degrees. From the diagram, BEC, meaning they are talking about this angle here. BEC is 75 degrees. Okay, let me ask you something. What do we call triangle ABE? We call triangle ABE a right angle triangle. That's one. 2, we call triangle ABE an isosceles triangle. Why? Because I noticed that this angle here will also be 45 degrees. Because sum of angles of a triangle must add up to 180 degrees. Okay. Now, having said that, we are looking at the questions now. Without the use of a calculator, determine angles AEB and CED. Remember, I said to you, when we write AEB, it's like we are saying to you, this is angle E, which is found between lines AE and line EB. So with that, line AE is this one here, line EB is this one here. So it means they're talking about this angle. Have you not found that angle? We have, and that angle is 45 degrees. But remember, you must write it down. Okay, so let's write it down. 45 degrees in that triangle plus 90 degrees in that triangle plus angle AEB, all equals to 180 degrees. Revealing sum of angles of triangle. This is a symbol for angles. Okay, so sum of angles, meaning when I add all the angles of that triangle, they must add up to 180 degrees. Okay, therefore, transposing everything to the right, leaving angle AEB on the left, we found that angle AEB was 45 degrees. Well done. Now let's look at CED. This is angle between line CE and line ED. Okay, CE and ED. So this is the angle that we are talking about. How do you find that angle? Okay, now we notice that these three angles, they lie on a straight line. Therefore, I can find CED using that. Okay, how do I do it? Let's write it down. Angle CED is equal to 180 degrees minus 45 degrees minus 75 degrees, which is 120 degrees. Now, 180 degrees minus 120 degrees, the answer for CED then is 60 degrees. This angle here is 60 degrees. Well done. Sum of angles that lie on a straight line add up to 180, or adjacent angles on a straight line are supplementary. Okay, now let's go to B. Determine the length of AE and ED. AE, we are looking for this here. Remember, triangle ABE here is a right angle triangle. We can use our trig ratios. 45 degrees this one or this one, it's up to you. But I've used the given one. So 45 degrees here is opposite AE and is adjacent AB. What is that? Tan trig ratio. So with an attempt to answer the question, I said, tell the marker in which triangle are you working in. Okay, so I'm working in triangle ABE, which means tan 45 degrees is equal to opposite AE adjacent AB, which is 4. Then I made AE my subject of the formula. I found that my AE is 4 centimeters. Okay, well done. Now, the question also said we must look for the length of ED. Going back to the diagram, where is ED? Our ED is right there. Okay, but I have an angle and I have a side CD. Remember, I said CD will be 4 because of the properties of a rectangle. So 60 degrees is opposite 4 and is adjacent ED, next to ED. What is that? Tan 60 degrees. It's a tan trig ratio. There we go. First, tell the marker in which triangle are you working in? In triangle CED. What do we know there? CD is equal to AB equals to 4. Reason? Both pairs of sides of rectangle are equal. Okay, and parallel. Now, tan 60 degrees in that right angle triangle equals to 4 over ED. Making ED the subject, I got 4 over tan 60 degrees, and ED was equal to 4 square root of 3, which if you punch in the calculator as D, then your answer in decimal became 2,31 centimeters. Okay. Now, when you punch in the calculator without using special angles, the calculator would have given you 4 square root 3 over 3 because you are using a calculator. But we found 4 over square root 3 because we are not using what? A calculator. We are actually following what? An instruction that says without using a calculator. But the answers are the same. Okay. Remember, the calculator rationalizes. Now, the last question to this problem, they're saying, hence, determine the area of the rectangle. Remember, how do we calculate the area of a rectangle? Area will be length times breadth. Okay. Now, let's go back to our diagram. From our diagram, what will be the length of this rectangle? It will be AD, the length. Then what will be the breadth of this rectangle? It will be CD or AB. Remember, they are equal, so it doesn't really matter which one you choose because we have both 4 and 4. Now, calculating the area, I said area is equal to, we said our length is AD times our breadth is AB. Then our AD, say, where does 6,31 come from? Let us check. Okay. AD from the diagram, remember what was AE? It was our AE, we found it to be 4 centimeters. That is AE. Then our ED, we found it to be 2,31 centimeters. But AE plus ED, they give us what? They give us the length of AD. Okay. Therefore, that's where the 6,31 comes from, which is the length of AD. So AD 6,31 multiplied by AB was 4. Therefore, our area for that rectangle ABCD is 25,24 square centimeters. Remember, AD is centimeters. AB is in centimeters. Centimeter times centimeter, then it gives us square centimeters. Okay, good. Now, did you know the following? Sin theta over cos theta is actually equal to tan theta. Did you know that? Did you see it? Okay, let me just show you one calculation where we've dealt with such a problem. Okay, it's very important for you as we are solving. You make deductions, you check what is happening, what am I getting, why are the answers the same, why is this and this like that. Okay, very, very important. So I want to show you that this is actually true. From the exercises that we have covered, you will notice that indeed this is true. Okay, and I think we are already there. Let us see. Good. There we are. Okay, look at this. You see, our sin theta was 4 over 5, and then from there our cos theta was 3 over 5. When we take the division of the two, which is in this slide here, we got 3 over 5. When we divide it, okay, oh no, this is not the one. When we divide it, there we go. Sin theta over cos theta, we got 4 over 3. Okay, and at the same time, when we look at the answer for tan theta, it's 4 over 3. So it's like we have 4 over 3 for tan theta, we have 4 over 3 for sin theta over cos theta, which makes them to be what? Which makes them to be equal. Okay, so whenever I have sin theta over cos theta, I can write tan theta. Or whenever I have tan theta, I can actually write it as sin theta over cos theta. They are equal. They are the same. Okay. Another one. Let's see. Did you know that sine squared theta plus cos squared theta is always equal to 1? Say, we're not sure, but we want to check. We want you to show us whether this is true or it's not true, and we will then take it from there. Say, okay, let's look at this. I said to you, pay attention to this. Cos squared theta plus sine squared theta is the same as sine squared theta plus cos squared theta. But what is the answer? The answer is 1. Okay, that's the first proof. Now let's go to the next proof again, where we had something similar to that, and we want to check whether, say, you are telling us the right thing or you are just doing a guesswork. Look at this. We were actually solving for something there, and the question said we determine sine squared theta plus cos squared theta, and our answer was also 1. Meaning, whenever we have sine squared theta plus cos squared theta, then our answer will always be equals to 1. Meaning, where I see this, okay, I put them in one place, then I can just substitute with a 1 because these are equal. What do we call this? We call them identities. And this will be covered in grade 11. So grade 10, please make sure that you meditate on these identities, because in grade 11, we will be looking more of these identities and applying them. Okay, and the good thing is in grade 11 there's only 2 identities, which are these 2 that I've covered now already. So in grade 11 it's more of working with them. Okay, in grade 12 you'll be having 4 more adding on your list, and it will be nice if you start by first mastering these 2. Okay, also to grade 11, make sure that these 2 identities, you know them, you can be able to apply them. Grade 12, make sure you know all your identities, including the ones that we have done in grade 12, because they are examinable. Okay, and this brings us to the end of the session. I wish you the best with your exams, and I hope you have understood all of the content that we've covered, and I hope you are going to do this over and over and over until you understand all of this. Sharp.